Hi everyone, welcome to week 7 of Forensic Science. We are finishing up September. It's going to go right here, and when this video gets finished, and there will be all the videos for September here. September was a fairly easy month, and I did not collect notebooks, and so watch for me collecting notebooks next week or so before we end. One thing I want you to know is that when September is over at the end of this week, all of this will go into its own folder called September. So you'll have to, September stuff, you'll have to log in there to get it, okay? Or not log in, but just open it up to get it. And I'm going to start a whole new row in a calendar for October. I would also like to tell you that on October 15th is the last day of the 9 weeks, and that is the last day that I have to that I can give you before I have to grade and hand in 9 weeks grades. So you have to be finished with everything by October 15th. And if you're not sure what you're missing, you need to go into Schoology, not Edmentum. You need to go into Schoology and look at your grades. Okay. So I'm going to go ahead and click on the calendar for September of 2020. When you get it there, I want you guys, it's this little button in the corner, always click that. It's a funny looking little X thing. And in this case, we're at the bottom. You scroll down here to the bottom, you'll notice that last week was a pretty easy week. We just did one tutorial and the mastery test, of course, with the guided notes. This week is the same thing. I've got one tutorial with a mastery test, and I don't have that linked right now, but it'll be linked in just a second. I want you guys to understand that the last 2 weeks I've given you fairly easy here for you to try to get caught up. But next week, week 9 is going to be a solid week. It's going to have all this blank space here and have things for you to do. So I need you guys working on this, getting caught up, so that when we start next week on October 5th, okay, Monday, October 5th is going to be a full week. So get ready for it, okay? I'm going to take you guys through the tutorial, which is, actually I want to go back to here. We're in Unit 2, which is physical evidence. We talked about collecting physical evidence a few units ago, then chemical analysis of evidence, then detecting evidence using light, and now we're going to be talking about trace evidence. I'd like to point out that this is it. Next week you're going to start out with a post-test, actually a unit activity and a post-test. Okay, so lots going on there. This unit activity is going to be work, and that's pretty much what you're going to be doing next week. Okay, but right now we're talking about physical evidence, and the last bit of physical evidence we're going to talk about is trace evidence. Now, trace evidence, whenever you see the word trace, that usually means small. A lot of times it means just minuscule, very, very light, and yet that is quite often one carpet fiber, okay, one small tissue sample, one piece of hair can make the difference between a successful prosecution of the criminal or the criminal gets away. And so we're going to talk about methods used to process and analyze any trace evidence gathered at the scene. So let's talk about first of all, let's talk about what trace evidence is. It's vitally important, although it's usually not the main piece of evidence that gets somebody convicted, but it's usually enough to what they call corroborate, which is a big word, but it means to assist, or more like help to explain along with the bigger stuff. So you've got bigger pieces of evidence, but these little pieces of trace evidence can corroborate alongside the bigger pieces of evidence to ultimately get a conviction. An example to try to offer you what trace evidence is suppose that a person robs a bank, they're caught on camera, and they know what type of clothing the perpetrator wore or whether they touched anything with bare hands. Now they can go look for fingerprints. Now the fingerprints would be a great piece of evidence, but the evidence of them touching something on the camera would be trace evidence. But that would, if I showed you both of those, if I showed you there's a fingerprint of a guy on the counter, this is that guy, the defendant's fingerprint. Oh, and by the way, look, here's a video of him touching the counter while he's robbing the bank. That connects the dots, right? Or if somebody, if the camera said that they wore a ski mask, and we can find fibers of ski masks at the guy's house or on the guy's hair, maybe even skin cells embedded in those fibers, can then lead us to have a conviction. So quite often trace evidence is like small, like really small, like you can't even see it with your what they call the naked eye, or the your eye without any kind of assistance. So there's a lot of technology that we use to look for trace evidence. Things like you just wouldn't believe, like, no kidding, oil secretions or sweat secretions in seats of cars, for example. And how do we find all that? Well, we've talked about some of these already, like mass spectrometry, mass spectroscopy, and infrared spectroscopy, ultraviolet. We talked about those kinds of things. Nuclear magnetic resonance spectroscopy is kind of like an MRI, kind of. Gas liquid chromatography is really cool because every chemical has a slightly different color when it burns, and we can compare that color to known samples. Atomic emission spectroscopy lets you measure the decay of nuclei. It's crazy. So as we work our way through this, we're going to be talking about what's important in these instruments. Okay, first of all is accuracy, and accuracy simply refers to an instrument's ability to make a proper identification of something with little error. Now, error is going to happen, and we know that, but the less error the better, and as a result I'm going to make this bigger. Okay, the less error the better, and as a result machines are sold based on their accuracy. How accurate is the result going to be? Sensitivity, then same thing. What's the smallest amount of evidence I could put in this thing and still get a result? That's its sensitivity, and that's the more sensitive the better. The more sensitive and accurate, even better. Okay, if it's highly sensitive and highly accurate, that's going to be a quality machine. Of course, that usually means expensive. Speed is another factor. We can't be sitting around and waiting while a lab has to process thousands of samples. If a lab has to process thousands of samples from thousands of different crime scenes, and it takes an hour per sample, that's just unacceptable. So we have got to get a machine that will do all of these things in a time scale that is considered acceptable, and sometimes that's literally in minutes. Remember, most of our stuff that, like in Okeechobee County, most of our stuff we send to labs. They do the testing for us, and then they send back the report. So we don't necessarily have all of this stuff in Okeechobee County. All right. And finally, automation, which is an important thing because that means that one lab technician can be doing several tests at a time, as opposed to one lab technician having to do one test at a time. Automation means that we can take large amounts of samples and push them through the entire process without having much human involvement. So here's the sample, okay, run it through the entire thing, and the machine does it by itself. This makes, again, even faster. It makes a lab be able to process more stuff, and so ultimately turn out more results at a quicker pace. So all of these things are the important things to have when it comes to the instruments that we use. Accurate, sensitive, faster than the faster the better, and then automated, which means that a lab tech doesn't have to stand there and just carry this thing through. And 20, 30, 40 years ago, lab techs had to do that. Every step the lab tech had to do. But now that we've invented machines that can do these steps for you, the lab tech simply has to monitor. And they can monitor several machines at once. They can have several machines running, and it takes a lot less people to run a lab, which means the lab's faster and more efficient and less expensive. So one of the main types of trace evidence is hair and fiber. We're going to talk about hair. You would be amazed at how much hair comes off of you. If you don't believe me, just go look at your mom's hairbrush or your sister's hairbrush or your hairbrush. Every time you brush your hair comes out. So think about how much of it just falls off your head. How many times a day do you brush your head against something, maybe scratch your head? Hair is always coming out. Hair can be used as evidence, and it doesn't have to be human hair. Sometimes animal hair can be used as evidence too. So being able to find a hair sample at a crime scene and then being able to make determinations about whose hair that is a very important part of forensics, and that's that's a very small thing, but it has caused many a criminal to go to jail. So if we look at a hair, a piece of hair, a couple of things we need to know. All right, we're gonna start out with the hair shaft. It's the outer layer of the hair. That's called the cuticle, right there on the outer layer. Right inside of it is the cortex, and inside of it is the medulla. Okay, so these things don't necessarily have much DNA. We can't get DNA off of these things, right? Just the hair. Like if somebody cut that right there, I hope you can see my mouse, but if somebody cut that hair, you're not getting any DNA. And so it can be used. There's what's called a scale pattern on it, and you can tell if it's a human or an animal hair. And then in the cortex there are pigments that can be used to help identify the hair a little bit. Does this come from a brown-headed person or a blonde or a brunette? But from the hair up, you don't get much. Okay, you can't do much. But if somehow, like if the hair got pulled out and this little piece right here that we call the root, okay, actually came with it, that has cellular tissue. All around there are cells, and so as a result, if that comes out, we can then get those cells and use those for identification. And so just depending on what we find. But if you get lucky, and you can probably see this if you ever go look at a piece of hair, and right at the very end there's just like a little knot. It looks like a little I don't know, piece of glue or something on the very tip, very small. That's the follicle, and it has DNA on it. So if you find that, you're golden. But if you don't find that, you can still determine some things. This come from a blonde-headed person. This come from a dog. And that would really sometimes help set the scene. Again, remember, trace evidence rarely is what gets us our conviction, but it helps to support the bigger evidence. Now, determining whether the hair came from a human or an animal is very important. So animal hair is very different than human hair in several ways. We're going to look at 4. Humans' hairs are pretty much the same color all the way through. Animal hair can change dramatically from one end to the other. It can be dark at the end and light at the tip. That's just a thing that animals do. In human hair, there's a size issue. There's a ratio. The medulla is smaller usually than the diameter. Well, you can read this. There's a ratio of the size, 1/3 to 1/2. With human hair, it's 1/3. With animal hair, it's 1/2. So animals have a larger medulla area than humans do. In human hair, the cuticle scales are always flattened, or what we call imbricate, and you can see that right here. They're flattened. Human hair, that's what helps make our hair smooth and shiny and lustrous and beautiful, but it's also flat. And when you look at animal hair under an electron microscope, you can see that it actually has some kind of almost like scales coming off the side. It looks like scales on a fish, and it's pretty easy to see very differently human and animal hair. And finally, if you get hair that's been cut, you can tell pretty clearly. Like if it's been cut, we don't normally cut dog hair except unless we go to a groomer. So finding cut animal hair is very rare out in the wild, but finding cut human hair is a little more common. So if you find the end of the hair follicle and it's clear to tell that this has been cut, not ripped or some other way sheared off, it's just cut, then that can usually suggest that it's an animal or a human hair, and that really helps. Okay, so if you're finding hair, knowing which is going to help. Again, the big word, corroborate other evidence. And now we move on to fibers. Now fibers are very useful, because when you find a fiber, oddly enough, you can get pretty close to matching these fibers to certain things. Fiber coming from rope is a little different than fiber coming from like clothing. And even on clothing, fiber from clothing can be made out of yarn or thread or all kinds of things. And between the fiber, the color, the chemical makeup of the fiber, you can add all these things together to find out some very specific stuff with just one fiber. And if you then are able to match that fiber to clothing or something else that the defendant owns, then you can sometimes put the defendant at the crime scene based just on a fiber. Two kinds of fibers: natural fibers, that's things like plant and animal fibers such as cotton is a natural plant fiber. Fur is a natural animal fiber. So if a woman's wearing a mink coat or something like that, or something along those lines, a man may be wearing a fur hat, I don't know, but that could really help out. If a guy always wears a fur hat because he's an evil Russian spy or something, and you find a piece of fur from a similar hat at a crime scene, you can use that as evidence. And there's even mineral fibers such as asbestos. Now, we don't use asbestos anymore. It's illegal since the 70s because it causes cancer, but it still is potential. And if you're a forensic scientist, you know what asbestos is. And then, of course, there are tons of manufactured fibers. These are fibers that are made from chemicals. They're produced. You've probably heard of nylon. You've probably heard of, I don't know, what else is there? Polyester. These are all fibers that, well, there they are, nylon and polyester. These are all fibers that are produced in one way or the other. There's regenerated fibers that are actually natural fibers that are then used to create something else like rayon and acetate. Then there's just flat out synthetic fibers where we just, from chemicals, build these things from the beginning. And either way, a forensic scientist knows the difference between all these different types of fibers and is able to, if they find them at a scene, draw some conclusions about them. Or again, corroborating the evidence. And the last one is glass. Now, glass can be very specific as well. Specific types of glass fragments come from different things because there's all kinds of ways to make glass. So if you know a lot about glass, then, and if you're a forensic scientist, you'll know this, then you'll know that this piece of glass may have came from a headlight, or from a beer bottle, or from a window, or you know, whatever. Also, you can examine glass for fingerprints because, you know, if it's a beer bottle, it's probably going to have fingerprints. You can examine the breakage pattern of the glass. That can tell you a lot. For example, as a bullet goes through a window, it will cause the glass to do a certain type of pattern, and you can well, first thing you can tell is, did the bullet come in from the outside of the house, or did somebody inside the house shoot it out? And you can tell depending on where the glass went, right? So again, I was just looking at clues, and you can learn a lot about things just by saying this window was broken by a gunshot, but it was not from somebody inside of the house shooting out. Somebody outside of the house shot in. What does that mean? So, you know, let's take a look at glass. So get a little specific here. Glass is what we call an amorphous solid. Amorphous means crystalline in a specific order. You put an A in front of it, it means it is not crystalline. It does not have a specific order. So the atoms that make up the glass aren't arranged in a crystal-like setting. So as a result, they break differently. Glass is often clear. It's often very brittle and breakable. It has a high melting point, which means that it takes a lot of heat to melt it. And there are 5 common types of glass. The first one is called soda lime glass. It's made mostly out of silica, but they add soda lime to it to make it clear. It makes a very consistent pane, which means that it's easy to see through. You don't see ripples in it. Tempered glass is another type. It's also called safety glass. The thing about tempered glass is that the way that it cools, once you've heated it, the way that it cools in a pattern so that when it breaks, it makes little kind of cubes as opposed to shards. If you look at the picture, if this thing were to come on apart, you'd see a bunch of shards there, and they're very sharp, and they can cut you. But the tempered glass, it breaks into little nodules. You've probably seen like a car window break, and those little nodules are far less chance of getting you cut. I've seen a guy actually take handfuls of it and put his hand and roll it around, and it didn't get cut. You see those on things like car windows and shower doors and stuff, things that if they break, typically it's because humans are using them, and we don't want these shards of glass. I know when I was a kid, I remember seeing a car accident, and the person had a shard of glass sticking through, I think, their cheek from the windshield. And that, you know, come on, really? But now that won't happen because we use safety glass. The third type of glass is called leaded glass. Leaded glass is actually glass that when it's made, it uses lead inside of it. Leaded glass is wonderful because it's so clear and so easy to work with. There is a problem with it, and that is that it has lead. So we don't use leaded glass that much anymore, and lead's bad for you. but you can test for lead and see that this little shard of glass came probably from a piece of art such as a figurine or a wine glass. Borosilicate glass is heat resistant. If you've ever seen a beaker in a lab, you ever seen them sing, I mean, they take a glass like beaker and put it and boil stuff in it. Well, that's borosilicate. It can take high heat. So it's also used for car headlamps, which is for strength as well. Borosilicate is usually very strong, very heat resistant, not necessarily very clear, although it's pretty clear. And you can definitely tell what kind of, like if you had a shard of glass, you could tell that, by doing a chemical test, this is borosilicate. So it probably did not come from a glass figurine, it probably did not come from a window, it probably came from a headlamp off of a car. And then finally there's tinted glass, and that's just used to reduce glare or decoration, and that also helps out too, because if it has a particular tint in it, you can use it to match things. So again, if I find a shard of glass, one of the things I'm going to be looking for is what kind of glass is it? Soda lime, tempered, lead, borosilicate, tinted, and that's going to really help me make some determinations about the crime scene and what happened. So also, when we find a situation where we find a fracture pattern, we can actually learn a lot from the fracture patterns. And I want you to think for a minute. Somebody had to study all this. Somebody looked around and said, you know what, that where somebody like hit that window with their fist versus that window being hit by a rock, maybe we can tell the difference. Radial fractures, this gets a little technical. They emanate from a point of origin, which means in the middle, and they work their way out. They work their way in a radial pattern. Radial lines tend to form a right angle on the reverse side of the point of impact, whatever the heck that means. If you're a forensic scientist, you understand this. You can look at this pattern and go, oh, well, that's because this happened. Concentric fracture lines are typically caused by something different. It was struck on the same side as a fracture line. Yeah, go figure that out. I highly doubt this is going to be in the test, but maybe know the difference between radial and concentric fractures. Write that in your notes. But the most important thing is that if you are a forensic scientist or a forensic technician, you can look at radial pattern or fracture patterns and draw some conclusions about what happened. Again, we get to a crime scene after the crime has been committed. We're trying to figure out what the heck happened. And every little bit of evidence, even the difference in how these patterns of glass were broken, can give us an idea of what happened. So, very cool thing about analyzing glass fractures patterns. And so we're done. You have gone through the entire tutorial. I know this went a little long, but I hope you've watched it. So, very simple week this week. Please, please, please get everything done and try to be totally caught up by the end of the week. It is crucial. You guys are doing great. I'm not too worried about you guys. You ought to see my biology class. Unless you're in my biology class, then you're doing well too. But get done so that next week we can get back on this and get going at a high rate of speed. All right, listen, don't forget, you guys, I'm on my Zoom every Monday through Friday from 9 to 11, and while I'm spending a lot of time with my biology kids, you guys could really use some help too. So if you need something, just follow the Zoom link. I'll let you in and we'll have a Zoom chat. It's the easiest thing, and probably 5 minutes, maybe even less. Most of my Zoom chats lately have been about 3 minutes long. So I am happy to have a discussion with you on anything that you need. Just look in your email for the link, and I'll have it turned on every day this week from 9 o'clock to 11 o'clock. All right, thank you guys, and I'll see you next week.